Assalamu alaikum students. The last lecture was about the conditional statements and we discussed about the truth value for the conditional statements. In today's lecture we will discuss about the biconditional statements and how can we decide the truth value for such kind of statements. Students, in this lecture we will discuss about the inverse, converse and contrapositive for the conditional statements. Then we will discuss how can we construct the biconditional statements and how can we use biconditional operator, and then we will discuss the construction of truth tables for the biconditional statements. Students, the inverse of the compound statements containing conjunction operator or distinction operator cannot be applied. However, for the conditional statements we can get the inverse of such kind of statements. For example, we have the conditional statement P implies Q, then the inverse of the conditional statement would be not P implies not Q. And you can see from the truth table that the truth value for the conditional statement P implies Q and the truth value for the inverse of conditional statement, which is not P implies not Q, is not equal. Therefore, a conditional and its inverse are not equivalent as shown by the truth table. We can also get the converse of the conditional statement, and the converse of the conditional statement P implies Q is Q implies P, but the truth value for the converse of the conditional statement and the original conditional statement would not be equal. Therefore, the conditional statement and its converse is not logically equivalent. As you can see from the truth table, the truth value for P implies Q and the truth values for Q implies P are not equal. The contrapositive of the conditional statement P implies Q is equivalent to the not Q implies not P, and it is important to discuss here that the conditional statement and its contrapositive are logically equivalent, and symbolically we can represent that P implies Q equal to not Q implies not P, and we can construct the truth table for the conditional statement P implies Q as shown from this column. Similarly, if we construct the truth values for the expression not Q implies not P, then we get the following truth values, and you can observe that the truth values for P implies Q and the truth values for the expression not Q implies not P are equivalent. Therefore, we can say that a conditional statement and its contrapositive are logically equivalent. Students, contrapositive of the conditional statement can be used to simplify the conditional statement, and the contrapositive property of conditional statement can simplify the statement of the theorem if it contains the conditional statement. Let us consider a theorem. Let n be an integer, then prove that if n square is odd, then n is odd. Its direct proof is difficult, and by using the contrapositive property, we can convert this conditional statement into its contrapositive. Let us consider its if part is denoted by P, and P is equal to n square is odd, and the then part of the statement is represented by Q, n is odd, then instead of proving that if p then q, we can prove that if not q then not p. It's mean now we want to prove that if n is even, then n square is even. So to prove that, we take n is even, and n can be considered as 2k because even number is a multiple of 2, and by taking the square of this n we get 4k square. This is also even because it is also a multiple of 2, and we have proved that if n is even, then its square will also be even, and its mean the contrapositive of the conditional statement has been proved, and therefore the original conditional statement has also been proved. Now we have shown that, and we have proved that if n square is odd, then n is odd. Now we discuss about the biconditional operator. Biconditional operator can also be used as a logical connective, and we can construct the compound statements. If p and q are statement variables, then biconditional of p and q is also known as p if and only if q, and it is denoted by symbol double arrow, which is given here, and we call it p if and only if q. It is true if both p and q have the same truth value, and it is false if p and q have different truth values. For example, if both p and q have both same truth value which is true, then the overall truth value of p if and only if q would be true. Even if both the truth values of p and q is false, then again the overall truth value of the logical expression p if and only if q would also be true. The word if and only if are sometimes abbreviated as if, and its notation is double arrow. Students, we have already discussed about the truth value of biconditional statements. The biconditional of two statements is false only when both p and q have different truth values. For example, if p carries a truth value t and q carries a truth value f, then the overall truth value of p if and only if would be false. Equivalently, we can say that biconditional of two statements p and q is true only when both p and q have same truth value. Students, the biconditional operator can also be considered as equality operator in propositional logic, and we can consider it as equal symbol for the logical expressions, and it is equivalent to the English phrase exactly when, only when, and if and only if. Thus, if we have a logical variable valve open, which is actually representing the sentence the inlet valve is open, and we have another logical variable mixer working, which actually representing the main mixer is working, and we have another variable normal state, which stand for system is in a normal state, then the logical expression valve open and mixer working is equivalent to normal state. Mean to say that only when the inlet valve is open and the mixer is working will the system be in a normal state. So normal state of the system is equivalent to valve open and mixer working. Now we come to the truth table construction for the biconditional statement, and we have a biconditional statement in the form of P if and only if Q, and it becomes a logical expression, and this logical expression has two variables. Therefore 2 to the raised power 4 rows in the truth table, and all possible combination of input truth values would be 4. And for the first combination of truth values where P is true and Q is true, then P if and only if Q would also be true, because the truth value of both the variable is same, then its truth value would be true. Now for the second combination of truth values, we have P is equal to true and Q is equal to false, and we have different truth values. Therefore the overall truth value for the biconditional operator and the statement containing this operator would be false. Similarly, for this possible combination of input truth values, the overall truth value would be false, and now we have both the variables have same truth value, which is false, and overall truth value is true. Students, the biconditional statement is equivalent to the combination of two conditional statements. Therefore P if and only if Q is equivalent to P implies Q and Q implies P. So both the expressions are logically equivalent. In order to show that both the expressions are logically equivalent, we can construct the truth table for both the expressions, and you can see that the truth values for the expression P if and only if Q is given here, and now we construct the truth value for the expression P implies Q and Q implies P, and in order to construct the overall truth value we need to generate the truth value for P implies Q, which is given here, and then we generate the truth value for the expression Q implies P, which is given here, and by combining these two columns with the conjunction operator we get the overall truth value for the given expression. And you can see that the truth value for both the expressions are same, therefore both the expressions are logically equivalent, and we can say that uh, biconditional statement is logically equivalent to the combination of two conditional statements. To understand the formation of biconditional statement, we rephrase the given propositions in the form of P if and only if Q. For example, we have a proposition in the form of for you to win an A grade in formal methods is necessary and sufficient that you have more than 85% marks, and its if and only if statement form would be you win an A grade in formal methods if and only if you have more than 85% marks. Now we have another proposition. If it is how if it is hot outside, you buy an ice cream cone, and if you buy an ice cream cone, it is hot outside, and its if and only if form would be you buy an ice cream cone if and only if it is hot outside. Students, we have already discussed that the biconditional operator can also be considered as equality operator. Therefore, the expression given on the left hand side of the equality operator and the expression given to the right hand side of the equality operator is logically equivalent, and to show that both the logical expressions are logically equivalent, we can construct the truth table, and you can see that the left hand side expression has the following truth values, and for the right hand side expression we have following truth values, and both the columns are same, as both the columns contain same truth values. Therefore we can say that both the expressions are logically equivalent, and you can see that this is basically the contrapositive of the conditional statement. We have a conditional statement P implies Q, and this is its contrapositive representation, and we can show that a conditional statement and its contrapositive are logically equivalent. And to show that this expression is overall true, we can also construct the truth value for overall expression. We can take the biconditional for the both columns, and we get the truth values which are all true, which is showing that this logical law is true. And this expression is also known as tautology, because when we get all the truth values for all possible combination of input truth values would be true, then that expression is known as a tautology. Students, we need to show that the expression given to the left hand side of the equality operator and the expression given to the right hand side of the equality operator are logically equivalent. And in order to prove that, we can generate the overall truth value for the expression given to the left hand side of the equality operator, and we can also generate the truth value for the expression given to the right hand side of the equality operator. And you can observe that the overall truth value for both expressions are not same. Therefore the given expression which are given on the both side of the equality operator are not same, and this can also be observed that overall truth value for the whole expression is not true. Therefore both expressions are not same. Students, we have already discussed that highest priority is given to the negation operator, and then for the compound statement or a logical expression containing conjunction or disjunction operator can be evaluated, and at the end we can apply the conditional operator or biconditional operator, whichever come first from left to right. In order to mention the precedence of logical operators in the given expressions, we can add parentheses, and the inside parentheses in the first expression is showing that we will apply first the negation operator, and the next parenthesis is showing that then we evaluate with the disjunction operator, and then we evaluate with the conditional operator, and at the end the left hand side expression will be evaluated uh, to the right hand side expression which is given to the conditional operator. And for the next expression, again the highest priority is given to the negation operator. Therefore this expression will be evaluated first, and then we will apply the conjunction operator, because we move from left to right. Then we evaluate new and old, and then we evaluate and modified, and then we evaluate or negation updated, and at the end the left hand side expression will be evaluated, uh, which is to the conditional operator, and whichever given to the right hand side of the conditional operator. In order to construct the truth table for the given logical expression, the highest priority is given to the negation operator. Therefore, the expression not or will be evaluated first. Then we move from left to right, and conjunction operator appears first. Therefore, we will evaluate expression P and not R. And by moving from left to right, we have disjunction operator, and Q or R will be evaluated then. And at the end, the lowest priority will be given to the equality operator, which is also known as biconditional operator, and we will get the overall truth value for the given expression. And this is the basically the order of precedence of operators in a given logical expression. Students, there are two biconditional statements. The first statement is not P if and only if Q, and other biconditional statement is P if and only if not Q, and both the biconditional statements are logically equivalent. And to show that, we can construct the truth table for both the expressions, and the overall truth value for the first expression is given in this column, and the overall truth value for the second expression is also given in this last column. And you can observe that the truth values given in both the columns are same. Therefore, we can say that both the expressions are logically equivalent. Students, the negation of the compound statement containing exclusive OR operator and the biconditional statement are logically equivalent, and this is an exercise for you that you actually need to prove that both the expressions are logically equivalent. And to show that, you can construct the overall truth value for this expression, and then you can construct the truth table for this expression. And once you show that the truth values for both expressions are same, then it can be proved that both expressions are logically equivalent. Student, there is an exercise for you. Suppose that P and Q are statements, and we have P implies Q is false. Then you need to find the truth value for the given expressions, that what should be the truth value for the expression not P implies Q, and what would be the truth value for the expression P or Q, and you need to find the truth value for the expression Q if and only if P. In order to find the truth values for the given expressions, you need to get the truth value for the statement P and statement Q. And how you can get the truth value for P and Q? This truth value can be obtained from the statement that P implies Q is false. And you know very well that P implies Q is false only when P is true and Q is false. Therefore, we can get that the truth value of P is true and the truth value of Q is false. And now, if we apply the following truth values In the first expression, we will get the truth value of the whole expression is true, and if we apply the truth value of p is equal to true and the truth value of q is equal to false, then overall expression would be true. And when q is false and p is true, then p if and only if q would also be false. Students, in this lecture we discussed about the inverse, converse and contrapositive of conditional statements. Then we proved that the conditional statement and its contrapositive are logically equivalent. Then we discussed about the biconditional statements and biconditional operator, and we discussed that biconditional operator can be treated as an equality operator, and then we discussed that how can we construct the truth table for the biconditional statements. Contents of this lecture are taken from chapter number 3 and section number 3.2 of the book Software Development with Z, and chapter number 2 of the book Formal Software Development from VDM to Java. Student, you must read the contents given in this slide, and that's all for today's lecture. Allah Hafiz.